Okay, in this video I'm going to finish out this last example on the note page, and then I'm going to do a couple problems from the homework just to walk you through them. So I posted that partial key, but I'll go through just a few if you need me to kind of walk you through them. So this one says additional counting techniques. Oftentimes counting problems include terms such as at least, or at most, or greater than, or less than, or between, instead of giving just a single number that needs to be chosen or permuted. In this type of situation, more than one case can be considered. So, Jack is setting a password. Sorry, there's the bell. On his computer, he's told that his password must contain at least 3, but no more than 5 characters. So this is still restricted to a few, but at least 3, no more than 5. He can choose letters or numbers. How many different possibilities are there for his password if each character can be used only once? So you can imagine if we opened up these parameters, there'd be a lot of passwords we could create, but this one's a little bit restricted. So A says, what are the possible lengths for Jack's password? So you first want to consider what could happen. Well, he could do it 3, because it says at least 3. He could do 4 or 5, but just no more than 5. So 3, 4, or 5 are kind of the outcomes. It says calculate the number of permutations. So right order does matter here. So what we're doing essentially is we're taking the 36 and we're going to figure out, well, if we permute 3 of them, that would give us all of the 3 passwords that we could create. Now, why did I choose 36? I actually forgot to explain that. 36 I used because there are 10 digits, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 that he could choose from and permute, or there's 26 letters in the alphabet. So total, there's 36 different characters that he could use, and then he's going to choose 3 of or permute 3 of them. Then if we do 36P4, that's the number of 4 letter or number passwords, and 36P5 is the number of passwords that could go there, right? And we could calculate each of those rather large numbers. So to find the total number of groups, we would essentially add all of these together. So if he could have it 3 digits long or letters long, he could have it 4, or, this is like our tree diagrams, 5, we would add all of those possibilities together. So if you add all of those up, and you can use your calculator to do so if you'd like to, or you can do them by hand. I don't know that I showed you in the calculator how to do it last time, so I'm going to really quickly. Perhaps I did. But we could go in and we could take our calculator and just input these. Get to see me skip that every time. Oh yeah, we must have done a few. So you can put this in all at once. I believe your calculator will do it. Let's see if it does. So we're going over to probability, and these are permutations, so I'm choosing that second one down, and I would put 36, permute 3, then we would do plus, go back to math, go over to probability, that second one again, 36, permuted 4, we do plus. Oh, the plus is down there. Yikes. There we go. Then we go back to math. Probability, 36, 5. And that gives me that total. So we can add those all together. Okay, so jumping to the assignment. Oh, that's not what I want. I'm sorry. You guys are going to think this is so crazy. It asks you to do a few different things. So on 2 through 4, it's asking you to determine the number of ways you could arrange letters. Remember, arranging is a permutation. So for example, if I'm doing number 4, I could take this and I could say, well, first of all, they want me to permute or arrange all of the letters of the word. So if there are 4 letters and I'm going to permute 4 of them, that would be 4 permuted 4. And again, we can plug that into the calculator. Or do that by hand, and you should end up with 24 as your answer. Part B, this one asks me only to arrange 2 letters of the given word. So there's still 4 letters possible in rock, but I only want to arrange sets of 2. So we are going to have 12 outcomes if you calculate that one. Okay, this next section asks you to do it by hand. So again, if I was doing, let's say number 10, I would have 300 choose 2. And this says use the formula, and this would be like my n and my r. And remember, I'm just going to remind you of the formula. N choose r was n factorial over r factorial times n minus r factorial. So I'm going to go ahead and put 300 factorial on the top over r, which is 2 in this case, 2 factorial, 300 minus 2 factorial. And then we simplify. And again, it's easiest to simplify the denominator. So that's 2 factorial times 300 minus 2 is 298 factorial. If that's the case, then I look at my numerator, that's 300 factorial, and I'm going to simplify it down until I get to 298. So 300 times 299 times 298. And I'm going to stop right there because we talked about that can simplify with the other 298 factorial. So in essence, this is just 300 times 299, which is 89,700, divided by 2 factorial, which is just 2 times 1. So we end up dividing that by 2, and we can get 44,850. Okay, so that section, I do need to see some work in your formula. The next ones, again, you're just working through these, deciding whether they're permutations or combinations, and then calculating. I'm going to show you maybe with like 15, kind of a simple one, and then we'll jump to another one. How many different sets of 6 questions for a test can be chosen from a file that contains 22 questions? Again, this is just choosing 6 of them. So this would be a combination instead of a permutation. Out of 22, we're going to choose 6. So you can, again, use the calculator on this one or go ahead and simplify it by hand. I'm going to show you that when I simplify this one by hand, I'm going to show you kind of what I do on this. Hopefully it doesn't confuse you, but we go ahead and plug it into the formula like we did on the last one with our n and our r. If I simplify the bottom, that's like 6 factorial, and 22 minus 6 is 16 factorial. So as I'm simplifying this, that's like 22 times 21, those were 23, times 20 times 19. This is actually going to get pretty long, times 17 times 16 factorial, so that goes away. So sometimes as I'm doing this, and this looks messy now, this 6 factorial, remember it represents 6 times 5 times 4 times 3 times 2. I'm going to write it over here, 6 times 5 times 4 times 3 times 2 times 1. And then I'm going to erase it right here. Sometimes what I'll do is if I know that like 5 times 4 is 20, that actually can get rid of 5 times 4 is 20, a couple of the factors. 6 times 3 is 18. So you can get rid of a few of those. Again, you don't have to do it like that. You can just use the calculator. But essentially when you start to simplify all of this, oh, that gets messy, we should get 74,613. Lots of different combinations. Okay, let's just look at one of these on the other page. That has to do with like order of arranging spots. So I want to look at 18D, 19D. So on 19 it says there are 7 children to be lined up in a straight line for a photograph. And D says how many different ways are possible if Hannah and Brian must be together. So this one we're definitely ordering the children. This one's a permutation. And it looks like there are 7 children, so we're thinking about kind of those 7 spots. And we're being asked if Brian and Hannah have to be together. Now, again, we are looking at moving them around. As long as they're together, though, they get to belong in here. So essentially, they kind of come as their own pair. So if you think about it, these 2 or any 2 are kind of like stuck together. And then we're permuting this other, well, I shouldn't make that look like a group. So it's kind of like there's 1, 2, 3, 4, 5, 6 groups. So we're taking those 6 groups and we're permuting them 6 ways. So we can move that group of 2 around. But these 2 also, Hannah could go first or Brian could go first. So there's really 2 ways or 2 factorial ways to arrange it within that group. So we would also times this by 2 permuted 2 ways. And then we can go ahead and calculate that. So again, we're just thinking about that as these guys are stuck together. So we call them one spot in the 7 spots. And then we reorder them within their own group. So that's why we multiply it by 2p2. Okay. So we'll just go through those few ones. And again, you're deciding permutation, combination, and then calculate either using the calculator or by hand.